Thanks for watching. I'm working more today on my stock market strategy. I made some really good results a couple of days ago, so I'm going to go over the strategy for the model, what I've done recently, and what I'm going to be working on today. So this is the outline of the strategy for the model. Real quick, let me make sure my screen looks good. It does. Um, Yeah, so this is the strategy for the model. First goal, beat the S&P 500 by a significant margin and make money in all regimes. So if the market's going up, I want to be doing way better than the market average. If it's going down, um, I want to be doing way better than the market average with the caveat that I'm not losing money. So it should make money reliably in any regime. Number two, so I'm writing all of this in Python. The model that I'm implementing takes under 100 lines of code to run. So I'm going to be generalizing this, I already have, into a Python tool that anyone can use to create advanced models for themselves. And as I add things to the model, I'm updating it on GitHub. So if you're interested in that, go check it out. The link to the repository is in the description. And you can create the model for yourself. So this is kind of the general outline. Oops. The first thing you want is a stock universe, so you don't want to train the model on all stocks. Certain things like penny stocks, low volume stocks, test tickers, ETFs, which have different price dynamics from common stocks, those are going to mess up your model. So you want to isolate a universe of useful stocks. The way I'm doing this is updating every month, getting a universe for every month and walking through the data. Once you have a good universe, then I'm training the returns model. This is predicting things like returns for the day, returns for the next 5 days, returns relative to the market, probability of a positive return, things like this. So I have a really good, robust returns model now. And now I'm working on this portfolio model level. So the portfolio model is going to take the output of the returns model and also take some macro level features like treasury rates, volatility index, um, and decide how to position a portfolio accordingly. Um, so let me show what I got yesterday. So this is the first good model that I thought I had. It actually wasn't good. There were lots of errors. I wasn't doing the universe correctly, so I was including things like test tickers for the NASDAQ, which never change in price, and so this was giving me artificially good performance. Um, I was also including a lot of stocks that I didn't want to include, so really I only want to have real estate investment trusts, common stock, and ADRs, which are foreign stocks listed on the US stock exchange. Um, so I tried improving this a lot of ways. Um, you see here the model really fell apart. It wasn't doing really well at all. This looks really bad. This should look like a smooth upward trend. If you're basically if you split the returns into deciles, um, the and then the um, split it into deciles, and the lowest values should be at the bottom, and it should gradually trend upward to the right side where you have your highest value at the top. So the top decile, the top 90% should be your best performing. Bottom 10% should be your worst performing, and it should increase linearly in between. Clearly, that's not happening here, so that was a bad model. This was a bad model. This looks better. This was the first decent model that I got, but still, it's not perfect. If you look at the metrics here, I have the targets on the left. So it's beating almost every metric. Information coefficient gives the predictive power of the model. Standard deviation of the information coefficient to information ratio, both on a daily and annual basis, and the t-statistic are giving you the stability of the model. So this looks like just good enough on every metric except the t-statistic. It's below what I need. After looking through and giving more improvements to the model, this is the result I'm getting at left here. So you see this is really nice monotonic increase in the decile analysis, exactly what I want. And then if you look at these, so remember what these were up here. Where is it? These targets. So 0.01 to 0.02 for information coefficient. Standard deviation of the information coefficient should be 3 to 13 times the information coefficient. Daily information coefficient to information ratio should be 0.02 to 0.03. and on an annual basis, it should be above 0.3. Now this model, it's blowing all of those metrics out of the water. So 0.047 for the information coefficient. The standard deviation of the information coefficient is, what is this? That's about 3 times the information coefficient, so way down at the bottom range of the goal. Information coefficient to information ratio daily is 0.3, so 2 orders of magnitude larger than what I'm going for. On an annual basis, it's 2.3, so about 1 order of magnitude higher. T statistic, I want to get 1.95. I'm getting 3.75, which is way above. So I did a walk forward analysis on this. So basically, this result is with 1 data split, which is nice, but you want to make sure it's more robust than this. So if you look at, if I give it 7 years of training data, 2 years of validation data for tuning the hyperparameters of the model, this is the performance. So basically this shows that every year it's getting an information coefficient above my target goal of 0.01 to 0.02, and every year it's actually above 0.02. Similarly, annual information coefficient to information ratio, I want to get 0.3, and the lowest I'm getting here is 1. Another really good indicator is that 2025, despite not performing that well, compared to some previous years, which gave crazy performance for the information coefficient, it's still performing better than the worst year, 2020. Same with the forward Sharpe ratio, and same also, the Sharpe ratio is basically telling you how robust your model is. So you need a Sharpe ratio above 1 for this to be implementable. And since I'm reliably getting above 1 for every year, I can conclude this is a good model. Also, information coefficient to information ratio, you see it's increasing. So the lowest year was 2020, second lowest was 2022. 2025, even though the information coefficient isn't that high, the information coefficient to information ratio is really good, 1.5, so 5 times my goal metric. And the last interesting thing here is 2022 is basically a bear market, slight recession, a slight pullback. And even though it was a recession year, not a severe recession, but a recession nonetheless, it's still not my worst year. So the recession wasn't the worst year for information coefficient or the stability of the model. So for these reasons, I'm going ahead and building the portfolio level model, which, like I said, is going to decide how to allocate positions in a portfolio based on the performance of the model. So I worked on that last night. Hey, Tech-Todos, how are you? Yeah, and tonight I'm implementing the portfolio model. So I was working on this last night, but I got stuck. So real quick, remind me of where I'm at on the portfolio. Let's just try to run it. And there's an error I'm getting. I don't remember the error. Oh, it's here. So let's see. Oh, it must be the same type. So I was looking at this morning. Remind me how to correct this error I get when I run the code. Here, I am using the portfolio optimizer.py that you have, and I've pasted my code below. All right, so let's give it the code. Don't want this. Oops. Desktop work stock market model, stock market tool. Okay. And then in Portfolio Explorer, here's what I'm running. How's my battery? Why does it say this on hold? Oops. Okay, so it's charging. All right, back to this. Oh, okay. So let's pass params. It does exist, you dope. All right, so feature engine, rate feature request, time period. All right, now let's see if this runs. Where's the PowerPoint? All right, real estate trends. Yeah, but if I'm doing that 18-year thing, I don't have enough data. Oh, this is interesting. So I still don't think there's any tankers moving through. Oh. Wednesday evening local time. So this morning. Interesting. All right, so it's going through and getting the features. Hey, Sing. Well, I'm still profitable, but not. Hey, Sir Night Night. Not nearly as profitable as I was last week, but I'm still up about 10%. And look, no ships are going through the strait. So, oh, here. So the traffic's been suspended again. So I don't know, is the US going to be able to stop Israel from bombing Lebanon? I don't see that happening. Maybe. But Israel doesn't care what the US says. Market breadth measures what percentage of stocks in your universe are participating in a move. So, what this is a simple version. What is the best practice standard used by quants? Okay, we'll wait for it. Okay, let's look at that next. Wait for this to finish. Diffusion index. This is what most systematic. Fraction of stocks with positive end day momentum across multiple look back windows. Oh my gosh, more. Herfindahl concentration index captures whether returns are driven by a few names or broadly distributed. Cross-sectional dispersion, the standard deviation of returns across stocks on a given day. High dispersion means stocks are moving independently. Low dispersion means everything is correlated. For portfolio level exposure model, diffusion index, 21 day and 63 day, why those days? Anyway, let's see. So I'm still, did I save this? Oh, did I save this? Yeah. Feature engine, portfolio optimizer. Okay. Add that. And then let's add portfolio optimizer. And then let's add portfolio explorer. Hey, Moonlight. Oh, I need to move this down to the bottom. Oh, after macro df is created before merge as of. Okay, so right before the merge. So where am I merging the data frames? So what's that doing? Macro df of date. So are they both date time? why would the second one be in microseconds? There should be daily data, but no microsecond data. So I don't want to convert to microseconds. Oh, feather files default to microseconds, CSVs default to seconds. Okay, so first, let me put that above. Fix date time error, feather files default to microseconds, CSV files default to, so what's the mismatch? Seconds. Do feather files default to microseconds, pandas. Yes. All right, so that shouldn't make a difference because we have dates anyway. So let's try this again. Okay, now let's look up here. So what is the importance? Diffusion index, cross-sectional dispersion, df of daily return is grouped by account symbol of close % change. That's % return. So what about here? Okay. And suggested methods for market breadth. Why do you use % change instead for the return instead of log returns? Isn't log return better? For diffusion and AD breadth, it literally doesn't matter. You're only checking the sign. Oh. All right. So this guy's still calculating. Rewrite the functions I want. Since these are not features included in feature engine, how do I incorporate them into the portfolio level model? Okay, computing transforms, so before it was failing here. Let's see if it works. Real estate trends. All right. Sorry, I have to send a text real quick. Okay. Cleanest approach is to compute breadth before constructing the optimizer, then pass it in. Okay, it didn't rewrite any functions. Key error VIX. The worker looks for data map raw VIX. Breadth features. Add 2 new phase blocks in compute. Insert these after the existing VIX loading block before 1.3. Okay, so before I can run this again, I need to test these features to make sure they work. Okay, first thing, this crap. Now let's add these features. That should be indented. Let's get this guy, phase 1.25. So after 1.2, before 1.3, feature engine, 1.1, 1.2, oh, this is good. Okay. Okay, so let's get out of here. Let's go to tests. Oh man. Okay, so what was the issue here? MySQL. Evil Levi. What's interesting? Oh, very good. What the hell? Oh. So if we go back to tests, so that's because I changed how model works. Okay, so back to tests. What line was this? 492. What? Tests. Tests. What line? 772 and get handle, 157 and read feather, 442 and init, 526. Okay, I don't want to actually change anything here. It's not in tests. Test features, test rate features. Okay, that one's on. Oh, test features. Oh. Okay. Did I add this to the GitHub test features? Maybe I could just change these. Remove it from the 3 naming lines. Oh no, I see. $13.35 to $13.37. Good. Okay, I need a sweatshirt. Okay, did it add anything else? Cross-sectional features and VIX Z-score. When 21-day diffusion drops below 63-day diffusion, it means short-term breadth is narrowing while the longer-term picture still looks healthy. Good thing I tested this first. One, two, three, four, five, six. Look at what the Israeli operation today was called. Operation Eternal Darkness. That sounds ominous. Alright, let's see how it runs now. Do these make sense? Alright, volatility z-score. I don't really know how to assess this. Okay, yeah, so I need to make sure the values are being computed correctly. Okay, I guess this is taking a bit. But I should just have to run it once and then we'll be good. Why is this taking so long? Okay, well the key is VIX Z-score works, so I'm gonna run that. I'm gonna run the portfolio optimizer and worry about incorporating the market breadth features after. Check. Eternal Assness, what is that? Oh, Eternal Darkness. Anyway, yeah, that is a pretty scary name for an operation, don't you think? So back to being bullish on oil. Anyway, let's see how this runs. Now I could look at, where's my PowerPoint for the physics project? Um, oh. Eternal Darkness. Okay, so Polytech, point and shoot field LDV, bridges, buildings, towers, 30K. Outdoor hardened, long range, SHM, hazardous areas. Range over 500 meters. Omatidia LiDAR. For industrial monitoring. Kientz makes a system that's less than 1 meter typical. Okay, so what are the requirements for civil infrastructure? How far away does the system have to be? If it is far away, my intuition is that 1550 nanometer fiber optic communication systems will not work. Okay, now it's optimizing the portfolio. Best value. Best value. Forward P&L 1.35. Oh, so it's deflated sharp, right? Or one to two is decent. Above two, we get strong. So we have one. Oh, drawdown. Yeah, that's right. Drawdown weight times max drawdown. Still at 1.35. Still at 1.35. So let me just try adjusting the drawdown. Yeah. Still at 1.35. 145, 146, 147, 148. Directly measures how much alpha opportunity exists when dispersion is low, even a good stock picking model. So width, breadth features. Oops. Oh, we got an increase, 1.44. So use all of them. So we're at 1.47. Yeah. So I'd like better than 1.47, but I think the market breadth feature should improve it a lot. We're 4/5 of the way through. Let's go back to looking at this. Omatidia, 100 to 300. Aligned along the bridge deck axis to capture deflection during live traffic. That geometry puts the sensor just meters to tens of meters from the target. Polytech's Heaney sensor head. So 50 to 300 meters. Oh. Drawdown gets down to 0.03 in 2020. But That's on a bad date. Monthly returns are mostly positive. So 1, 2, 3, 4. So it fails going short right after the COVID crash. So 50% return over 6 years. I guess that's good, but it's not great. 2022 when the S&P was going down, it still gave nice returns. .03, so 3% drawdown. Not bad, but I want the rolling 60-day sharp to always be, ideally it would always be above 1. So I need to run it on train years and test years. Oh. Damn it. So back to Portfolio Explorer. Let's just do 100 trials, draw down weight 3. Train years equals 4, test years is 1. So train on 21, 20 and 21, test on 22, 23, 24, 25. Train on 2020, 21, 22, test on 23, 20, I want to test on 22. Test on 22, 23, 24, 25. usage limit reached. So maybe I could just change train years to 1, test years to 4. So we have VIXY score. Rate spread, rate butterfly, rate spread, rate butterfly, rate velocity. Train years, test years, is there anything else? End trials. C divided by pi times del V. So still the worst drawdown is about 3%. What is this plot? What the fuck? end of 23, it did incredibly well. So basically it did really poorly during the tariff crash. But now we're getting a 20% return. And here it's at 1.04, so that's like a 15% return. So there's a trade-off between how long I train the model and how good the portfolio level model can be. Okay, so let's do this, but I better finish up. So test portfolio 2, let's add these other features. Test features. Okay, let's wait for this to finish. turn this guy off. Now we can run this. Let's see. So what was the best I got? 2.69. That's pretty good. Okay, so that's it for tonight. Thanks for watching. Tomorrow I'm gonna look more into this guy, see how can I maximize the portfolio optimization. But this is good progress. We got the portfolio optimizer to work. It's running. I'm just not getting the returns I want. So I'm gonna work more on this tomorrow. Thanks for watching. Have a good rest of your night. Adios. Tomorrow I'm gonna look more into this guy, see how can I maximize the portfolio optimization.